Now let's move on and complete our earthquake load definition. Okay, let's move back to load pattern. Load pattern for lateral load, we have few options. So one is using user loads. So if I want to change any lateral load pattern here, I need to change it here, but it wouldn't be automatically changed. I need to come here and press on modify load pattern, then that will be changed. Then I need to come to modify lateral load pattern, and now I can see that. The user load application means you need to manually calculate and apply lateral load in X and Y direction, and also accidental torsion that you may have for that actually point. So you can apply this one at the center of mass because you have diaphragm. This option wouldn't be activated if you don't define your diaphragms. So you need to have the diaphragm to be able to use this option for user load. So you need to apply to the center of mass, or you need to specify the actually coordination of the location of applying this load. But you may need it for some very specific cases to apply earthquake load manually, but this is not very popular way because SAP can calculate it automatically. So what I will do, I will leave user coefficient. Later I will just show you what else is available. The other option is using any of those standards. If one of your local standards are defined here, SAP can automatically calculate the lateral earthquake load based on the factors you actually putting in as a data. So if I use Australian standard, which is my local standard, again I need to here and change modify load pattern and then modify lateral load. So that gives me the option that I can put all actually factors I need to allow SAP to calculate the earthquake load based on Australian standard. So here I need to define is the earthquake will be applied in global X direction or Y direction, and then what is my eccentricity ratio. Eccentricity ratio, for example, if you are applying load in X direction, eccentricity ratio would be normal to the direction of application of earthquake, so is in Y direction. And you need to put here the percentage of the dimension of the building normal to the earthquake load, and mention, for example, 10% of this length will be considered as accidental eccentricity. There is an option for override diaphragm eccentricity, but I'm generally not using this, that I define the eccentricity myself. So I leave it to the program, and there are the factors that we use in Australian standard is similar. You have an approximate factor for based on the period, or you have the program calculated factor, and you need to put the user defined for the fundamental period for basic calculation of the earthquake load. And then here there are lateral load elevation range, which is very important, because when you mention program calculated, program automatically calculated from the lowest level to the highest level. All of them will participate in earthquake, but this is not what we want here, because we know that up to Z0 the building is fully confined with retaining wall and soil around. So actually our base level in earthquake for this model is ground floor, and when we say ground floor, that means even ground floor slab shall not be taken into account in earthquake load. So you need to come here to user specified always if the building is not just with shallow foundation and going up, and you need to define here what level you need. So here currently is 0. So soil subclass A, B, C, D, E, this is Australian standard again. What's the other factors I need to add, and hazard factor, everything. When I put all of them and press OK, that will be automatically calculated by software. So this is what you can do if you prefer to use any standard. I personally always use user coefficient because this is in my control. I can see what I have done, and I don't want to be lazy. Honestly, as I said, I don't want to be an operator. So if I leave everything to software, after a while I may forget even how to calculate earthquake load, which is not good. I don't like it. I rather see what I do. So I'll change this one again to user coefficient by applying modify load pattern, and then I'm coming to modify lateral load pattern. So I will update this one for this model. We talked about this abbreviation EQXP, means earthquake in X direction with positive eccentricity for Y direction, which is normal to X. So load will be applied global X direction. Eccentricity ratio, as I said, is 10%. So this is P, that means positive. So I just put positive 10%. And then I'm coming here to user specified. I'm using 0 here. Australia, really earthquake base shear coefficient is very low. It's sometimes even 3%, 4%. The worst case scenario could be something between about 20% for non-ductile elements. So 10% is pretty higher than average for earthquake loads. I will leave it here. And building height, this is a factor based on the period. It could be more than 1, but minimum is 1, so I will leave it here. All again, those are Australian standard. Please don't be confused. You shouldn't use exactly the same factors. You need to see your local standard, and I'm quite happy to help you when you prepare your own model. So I will keep it very simple like this and press OK. Now I need to do the same for other. So here again, global X direction, but this one accidental eccentricity is negative. So I need to come here and mention minus 10%. And again, user is 0, and I leave it this 2. For YP, I'm coming here and change it to Y. Again, this is P, so it's 10%. SAP automatically understand when you calculating eccentricity ratio, it should be normal to the direction of the application of earthquakes. So don't worry about that. And that would be 0. This is okay. And this is the last one. I'm coming Y. Minus 10%. And here 0. And this is okay. So this is done for earthquake load. Just to save for any case if I miss anything, I press OK, and I generally frequently save my model, ensure I'm not missing anything. Again, I will back to here to define my wind loads. I talked to you guys about wind loads. If you remember that there are again different options here. You can go for standards, you can use your user define. So if I, for example, come here and find Australia New Zealand wind load 2011, I need to put modify load pattern. So it's coming here, and then when I put modify lateral load, I have all those factors, and I can define what exactly I need. What's the Z specified? Again, the wind wouldn't be applied to lower than ground floor. I need to change it to 0, and I need to put regional wind speed and train category and other factors we're using in Australian standard, and also windward factor and leeward factor coefficient. And you can put all of them here, and that would be automatically calculated. So when you said windward and leeward, then when you are in X direction, that should be actually SAP should automatically figure out which one is windward and which one is leeward. I personally, again, I want to feel what I'm doing. It's okay, many people are using this, but I personally rather calculate myself directly and figure out what I'm doing and apply load. This is my own way, guys. You don't have to do that. It's really your responsibility. As I said, you need to take full responsibility of your calculation. If you feel confident, if you know exactly what's been done here, you can use typical method here for calculation of wind load and leave it to the software to calculate. But SAP doesn't apply load at each individual element. It applies load to the center of mass. But I personally prefer to calculate the tributary area of each column, apply wind load manually, and see exactly what's going on. There are lots of things in Australian standard specifically. There are different loads that we need to play. Is not just X and Y, it's not just leeward and windward. We have roof load, we have internal pressure, and we have different factor, because when the combination of all loads are in the game, you don't have to apply 100% of all of them. So if could be up to 80% of each of them. So I do prefer to do it myself. I will get back to user defined. And press modify load pattern, and then here for this I'm coming to modify lateral load pattern. You can see here diaphragm. So as I said, SAP will apply the load on the diaphragm. It doesn't work for you if you want to see the effect of wind load on the facade, and columns were supporting facade, especially for light frames like this. So that is good just for having the base shear and general bending on all elements and probably core walls. But if you want to design this column, if the column is very strong, concrete column probably is not important, but if it's for example a tiny column like in a steel column or wall post, you need to see exactly what's the moment on this column to be able to design that column properly. So I'm not very fan of using automatic load here, even user defined. So what I will do, I will go for none, and I will apply wind load manually myself. I will show you how to do that. So I'll change all of them to none, modify load pattern. Modify load pattern. Okay, so this is what I want to have. So I have user coefficient. Just bear in mind when you're using any standard, SAP automatically create other options. So when you put this one, you can see all of them are coming here. So you can see that what's the wind in each direction. So we have 4 different wind categories that SAP will create when you want to use any standard for example, X direction, and the same for Y direction. If you want to do it manually, then you need to remove them. It's really up to you guys. So delete load pattern. I will delete them. You guys can do this practice with your own local standard, and if you have any question, you can ask me. I don't want to make you confused by using my own local standards, because you may use different standards, so it may not make sense for you. So I will keep it simple, and I apply loads manually. So just need to ensure that there is nothing additional here. I will get back and double check what you have done. Okay, so I press OK. So if I come here again in my load pattern, I can see I have user coefficient for earthquake, and I have none for wind load. So this is exactly what I want. So that's the definition of load patterns. I hope it's clear the options you have for wind and earthquake. In next video, I will talk about how to define load cases and load combinations, and after that how to apply loads.